So I hope I opened your appetite a little bit. Now let's take a deeper look at and examine an example of doing LOP. We will use internal DSLs. So this is our task. We need to implement a very simple parser for a very simple grammar here. We will do it LOP style. That means that the first step would be to translate this grammar into some imaginary domain-specific language. The next step would be to make this imaginary language concrete by actually implementing it, by actually providing meaning to its constructs. So, and we will be using Prolog as our host language for this example, and for reasons that you will see soon. So this is the first step. We take the grammar specifications at the bottom, and we translate it into some imaginary language. This DSL that we just implicitly define what is actually a DSL for BNF. So in our DSL, this is how it shows to depict production rule, a terminal, concatenation, and an empty string. These are the four constructs of our DSL. Now, the next step, which is the last one, is making this language executable. So the first thing we do is we need to define the : equals operator as an infix operator in Prolog's extensible syntax. So this is how we do it. Now we need to implement the semantics. For that, we will implement a predicate called parse that will allow Prolog code outside of our DSL to call grammars defined in our DSL. So parse has 4 clauses, each defining one language construct: the empty string, terminal, concatenation, and the production rule. Now, the production rule is defined in a different way than the others, because for Prolog, the : equals operator is actually a predicate. So we define parse in terms of the : equals predicate. Now, I know not all of you know or remember Prolog, but this is pretty nice and elegant for those who do. But it's not free of limitations. There are 2 significant limitations to this approach. One can be seen here, and it's the fact that we extended Prolog's syntax. And it's all nice and simple when we have just one DSL, but remember, our goal is to have many of them, like 5 or maybe 10 different DSLs. And when we do, there is no guarantee that there is no other DSL that is totally unaware of ours that will have a different but conflicting definition for the : equals operator. Another limitation is a semantic one. We did not define our DSL in any way. Well, we did not give a concrete definition of our DSL. We define it implicitly by using it. So what if we used, say, braces instead of brackets in our DSL code? Prolog would not know that it's wrong. It would not know to give us an error, neither at compile time nor at runtime. What we would get sorry. What we would get is a bug, because Prolog will ignore this rule.